Hi everyone, CC Solar here. So this is a simple solar system, and all of this is materials that you can buy in your local hardware store. The materials that makes this simple structure is basically materials that you can find in your local hardware store: the concrete, the electrical beams, the cutoff switch, and this here is the cutoff switch, and this here is the combiner box. So let's take a look inside the combiner box. So this here is the combiner box, and this is also easily made. It's a simple electrical box that holds electrical sockets, and simply drill 2 holes manually at the bottom there, and you have the cables coming in for the solar panels. So this is 40 volts coming in from the big panel, and then I went ahead and I got 3 smaller 12-volt panels that I went ahead and I connected in series to build the voltage up, and now I get a little bit over 40 volts. So if you take a look in there, that's how that's all wired in. Series just means negative to positive, and you connect the panels that way to build up the voltage. You build up voltage by connecting solar panels in series, and if you've got mismatched panels, this is one way to go ahead and connect them, because your solar panel system is only as great as the panel that has the lowest voltage. So since I'm connecting a 40-volt panel with mismatched 3 individual 12-volt panels, I had to build up those 12-volt panels. And one thing that you should understand is that the 12-volt panels, when you buy a 12-volt solar panel, it means that it's actually more than 12 volts. It's actually about 20 volts, because you cannot charge a battery if the voltage than a 12-volt battery is less than a 12-volt battery. So you need solar panels that produce higher electromotive force to push a higher voltage, to push power into your battery system in order to charge your battery system. So taking a look at some of the hardware here, what you have here is simply an electrical store hardware part that connects these beams here, and these are all bolted together with bolts, nuts, and washers. And this here is simply your clamp system that I'm using, and this also can be found at your local hardware store. And these V-beams that are going out here, this is all for support of the panel, and you want it also tilted. The panel, if you look at it from this angle, it's a bit tilted so water doesn't collect on top when it rains. And this here is also a L bracket that's connecting the V-beam to the upper racking via bolts and nuts washers. So now we'll take a look at the cutoff switch, and currently everything is on, so we have to be careful. So this is what inside here looks like, and this is just simply the combiner box where you combine all the panels coming down via conduit into this cutoff switch then it comes down into this conduit here that goes underneath the earth. I bury the cable and into the home and connects to a battery system, which I'll show you in a little bit. But here is basically the cutoff switch. So in theory, this is all grounded because of this beam here. It's all grounded. However, just to keep everything safe and proper and somewhat within code, you want to go ahead and ground things properly. So here is your panel that's grounded there, and it comes on down and it comes into that copper exposed bare wire. So you're grounding your unit, your combiner box wires in there, and you're also grounding your shut off switch in there, and it all basically is connected here to your grounding lug, and then that's connected to this beam here that's going straight into the earth, that concrete encasing. And this beam is actually about 3 to 4 feet buried in the earth with this concrete structure, and this supports it very, very well. It supports this entire unit just perfectly. It's withstood winds and rain and storm, and so far it's been holding up very, very well. So this here is the battery system that the solar panel is connected to. However, it does go to a charge controller first, and then it comes to this battery. So here, as you can see, this connection here goes on into the house via that box, and the yellow cable coming down, that's basically the solar coming in, and this cable here is the battery that's powering the house. So this here is they're called Anderson clips, Anderson connectors, and I find them very, very useful in comparison to the MC4 connectors, and they're very easy to use. They're easy to disconnect. It's just an absolutely all-around wonderful and convenient product to use when building your solar system. Okay everyone, so this here is a compact system, and this is where the panel comes in to feed this entire system here, and it's built very compact in a toolbox, because if you live like in an HOA or places that are strictly governed or whatnot, like very anti-progressive type places, this is a very progressive type of system and makes it mobile, and it allows you to actually have solar underneath the radar. So I want to show you that you're very capable of building an entire complete system as small as this in just a toolbox. So you've got your charge controller, and you've got your combiner box, which I'm going to show you in later in this video, and you've got an automatic transfer switch, I will explain, and you've got the inverter. This is actually 5,000 watts. That's well capable of powering an AC unit, heater. It actually powers in this entire room, the security system, the Wi-Fi, the Google system. It's capable of powering quite a bit. So, so the sound you're hearing right now is actually the inverter being cooled right now because it's producing so much power. Right now, it's later in the daytime, so there's not a whole lot of light intensity. So we only have 193 watts coming in from that 500 watt solar panel system. And that's only half a kilowatt. And that's more than enough power to power everything in this room here and more. So if you look at the parameters here, I'd just like you to have a look at this parameter here. We're going to go ahead and zoom in on that to have a better look at that. So you have an idea of what to buy. And this is Power Mister charge controller, and it's MPPT. You want to get that. It's much better than a PWM. So this here, and I'll explain the difference between MPPT and PWM, or you can actually Google videos on those that explains the difference. But MPPT, it's much more better at tracking the light intensity. So this here is where the solar panel that we spoke about earlier comes on in. It goes ahead and feeds in here. We only have 188 watts coming in and only 40 volts. Remember, volts is the electromotive force, and with the more light that hits the panel, that's what drives the amperes in to charge the battery system that powers this room. So here, so this is the charge controller, and this here is an automatic transfer switch. So what the automatic transfer switch does, it allows you to connect your battery system alongside with the grid system without getting in trouble, so to speak, with the power company, because the power companies and the grid companies, they highly discourage this type of system. They don't want this to happen. They don't want people to have solar. They don't want people to use wind. They would rather you just be dependent on the grid. But the problem is that the grid is not reliable. There are blackouts, there are freezes, there are storms, there are hurricanes that occurs, and if you've got sickly people and old people and babies, then you need a backup type of system to have power if the power does go down, to power your fans or whatnot, to cool the place down or produce heat. So this system here actually allows you to use it alongside the grid system, as I have said. And this automatic transfer switch, this here, when the voltage drops below a certain voltage, it will automatically switch to the grid system, and it's actually plugged in right here. Let me go ahead and show you. If you look back here, it's actually plugged into the wall. You're going to see this system plugged into the wall via this cable here. It plugs in, so it'll pull power from the grid, the grid to power this room when the battery drops below a certain voltage. And when it rises above a certain voltage, as currently now, it's actually on battery system. So this entire place is actually being powered with a battery system. So this here are the Anderson connectors that I told you about earlier. They're very, very wonderful, very, very efficient, very easy to use. They come in here, and there's actually breakers in here that protects equipment. And this here is your solar actually coming in, and it of course goes to a breaker here that protects the charge controller. Remember, breakers are mainly used to protect equipment. Always understand that. So whatever you want to protect, you put a breaker in between the equipment and the device that is pushing power into that equipment. So this will trip before this gets damaged in case of a surge or whatnot. And all this here is grounded. This here is actually a ground clip that goes back to, this actually travels all the way via conduit straight back to the panel and into the concrete encased strut that's supporting the entire solar panel system. So all this stuff is well protected. If there's some kind of surge or anything like that, there can be no fire or any type of disastrous thing like that occurring, because all that excess voltage will actually travel back to its source, which is the ground. Remember, electricity, it's always looking for a path back to its source, and in this case, it'll go back to the ground. So this here is a switch that shuts down the entire system. If there's any problems or anything like that, this switch actually shuts down the entire system. Of course, I can isolate certain things by using the breakers. So this here is a breaker that, instead of shutting this down, if I wanted to work on the solar panel or work on this charge controller, I can simply disconnect the solar panel to this charge controller via this breaker. However, this will still have energy in it because it is connected to the battery, and only this will shut down the battery system. So to keep things safe, you always want to just shut down everything when you work on any type of equipment, and you're going to shut it down via this switch right here. That fan you just heard is the inverter being cooled. So this here, what you're looking at, is basically more like the combiner box for this system. So here, this is a very mobile type of system. You can actually shut this down, close the lid, and take it in your van or RV or your other home or wherever you need to take this system. It's very, very, very mobile. And this here is a breaker that protects this inverter, okay? And we'll go ahead and take a look at that inverter. It protects this 5,000 watt inverter here. This is actually a 12 volt inverter that transforms 12 volts into 120 volts. So this will actually power appliances in your home. It could power up to 5,000 watts, which is an enormous amount of power. AC unit, heater, whatnot. Heaters only take about 13 to 1500 watts. Some smaller heaters are 700 watts. So this will actually power a couple of heaters depending on your battery bank. Everything depends on your battery bank. So these two terminals that you're looking at here are basically extensions of the battery. So imagine you have a battery, you have a 12 volt battery, and there's two terminals. You have a negative and a positive. So basically you want to extend those terminals out, and you've got your positive here and your negative here. These are just hands that reach far. So you've got basically everything that connects to these two terminals, excuse me, these two terminals here that's in this box. And you connect everything to the two terminals, you screw it on, you secure it, and this is how this works. Okay, so this here again is a charge controller, and as you can see, the wattage is very, very low. And as I told you before, one way to keep this entire system safe, let's go ahead and zoom out so you have a full picture of everything. The transfer switch, the combiner box, and the charge controller. So here we have all the components. You can see the inverter here. So one of the things that if you wanted to work on this charge controller, as I've told you before, you wanted to work on the solar panel part of this, there's a breaker that protects it. And if you simply, you see the numbers here changing, the voltage, the watts. If you wanted to completely disconnect the panel from this charge controller for whatever reason, you could just simply push this breaker here, and you could see that it's disconnected. Everything is zeroed out. So when I go ahead and push this back in, it goes ahead and starts it back up. You've got electromotive force, you've got wattage coming in, amperes coming in, and you're back charging your battery system. So thanks for watching. We appreciate it. This is CC Solar. Have a good day.